Hello everyone, today I am hereby to give a presentation of air traffic control for delivery drones. Myself, I am GSI Identity having a PIN number of 21955821009 and my topic is air traffic control for delivery drones. Abstract. In 2011, in 2013, shortly before Christmas, Amazon.com released a video describing its plans to speed packages to the destination using small drones. Some commentators said it was just a publicity stunt, but the notation began to seem less far-fetched when Google revealed its own drone-based delivery effort in 2014, something it called Project Wings. And in the early months of 2016, DHL actually integrated drones into its logistics network in an extremely limited way, delivering, delivering packages to a single mountain top in Germany that is difficult to access by car in winter. Introduction, topic, and main hypothesis. It started to get momentum after senior players came in, says NASA senior engineering for air transportation system, who has been researching way to work this using little contributions into an air traffic control system created for created for full size aircraft. We need to accommodate drones. This past August 2017, the US Federal Aviation Administration FAA introduced Part 107, also known as the Small UAS rule, which allows companies to use small drone in the day night or during twilight and within visual line of sight of the pilot, so long as they are not flow over people who are not participating in these operations. In 2017, promising to see the FAA's drone rules loosen even more. At the Inter Drone Conference in Las Vegas in September 2017, FAA head Michael explained that his agency was drafting rules to allow drone to be flown over random bystands, and that it plans to release proposed regulations to that effect by the end of 2016. We are also working on a proposal that would allow people to fly drone beyond visual lines of sight, he said. Such a move would open the door to use small drones to deliver package among other things. Of course, when you start flying drones where you can't see them, you need to put technology in place to be sure that they do not hit anything or injure anybody. With the details of how exactly to do that remain to be armed out, there is no shortage of idea. One of the companies working on this challenge is Precious Op, based in Release NC. It's one of just two companies to have obtained a waiver from the FAA allowing it to fly small drones beyond the operation visual line of sight. For such flights, the FAA thus, however, requires that an observer be posted to look out for full square aircraft. Still, the waiver increases the range of company drone operation from how far away you can see a small aerial vehicle, typically a kilometer or less, to how far away you can see a full-size plane, 6 to 7 kilometers. The waiver does not allow a 200-mile straight line flight from A to B. Notes, nevertheless, is ordained by the much broadened area. The exception permits the engineering at Precious Arc obtain the waiver in part because it had created a system to help drone pilots safely operate a vehicle that they can't directly see. Avoiding with a full size aircraft is job number one, of course, but the wall. But the more typical danger is much more modern, running into a tree or a wall. To avoid that, Precious of have uses satellite image to create a detailed tertiary model, one of the sufficient resolution to capture how high each tree and building is. The system continuously updates that model as new satellite image becomes available. Flight planning software, or even the autopilot on the drone itself can then use the information to avoid obstacles. Precious Arc has also worked out a mechanism for drone operators to get updates through cellular network on the location of full-size aircrafts, the same sort of information that air traffic controllers have, and drones reports their position over the same wireless network. So air traffic controllers and pilots can, in principle, know where their missions are. What we are providing as a product is primarily the software and data, says Tyler, the creator of the system, which goes by the lattice. We want lattice on every drone. Precious Arc system, the strategy that is increasing being used to manage full-size aircrafts, whereby those aircrafts determine their position using GPS or some other form of satellite navigation and broadcast that information by radio to everyone else. The equipment for this form of air traffic management called ADSB for automatic dependent surveillance broadcast will be mandatory on most US aircrafts by 2020. It is the fear of Amazon's idea about the drone. Amazon is stressing a hybrid drone that takes off and lands vertically but flies like a plane to its destination. Such drones could one day speed packages to consumers. While it might seem sensible to include small drones in the upcoming ADSP, doing so could easily overwhelm that system given the huge and growing number of drones they are selling at the rate of 2 million a year in the US along according to the FAA. With those numbers growing so fast, an independent scheme for drone traffic management schemes inevitable. NASA, Google and Amazon have all been contemplating what such a system should entail. While the concepts that have been outlined vary in many ways, they are all similar in that they could restrict drones to the first few hundred feet above the ground and to location they are well separated from any airports, that is, to parts of the sky full-size aircraft rarely visit. At the airport in Reno this past October 2017, NASA and various industrial partners carried out trials meant to help establish detailed technical requirements for a drone traffic management system on that would allow delivery like the one depicted in the 2013 Amazon videos. So whether or not it was publicity stunt, perhaps this indeed is what the future holds. As of Procedure Ox says, we actually does not think the future is very far. Conclusion. Conclusion of his presentation. Drones will eventually be successful in the last mile delivery space for the three main reasons: cost, value of fast delivery, convenience. With reasonable cost of less than $5,000 and fast speed deliveries of less than 20 minutes, the row are bound to succeed in delivering the last mile for both the brick and mortar companies and large internet retailers. For brick and mortar companies with a nearby local presence, delivery will become faster and more convenient. For a large internet retailer like Amazon, it will need to build out warehouse close to where people live in order to compete on speed that the traditional brick and mortar will have. It will make the deliveries happy, faster and at a more economical prices, therefore helping fuel the adoption of the drones for lightweight deliveries. This will create a supporting ecosystem and the surroundings industry will be will be able to create value for everyone and make the end consumer life better. The first adapter will likely win as they will be able to run faster, illiterate and establish their brand name as a cheaper and faster companies to deliver packages. Example of some companies that are ahead in the space are Amazon and Walmart, which are already testing the drones and are ahead of the game. This will be a great boost for them in the long run and enable them to stay competitive and earn new customers given the cost, convenience, and speed of delivery. Thank you.